Welcome back, student, to ALC class. Today's topic is Turing machine formal definition. We will see the formal definition and we will see some of the examples. So, in the previous class, we saw the introduction of Turing machine. Just go back to the previous video, and if you did not understand anything here, you can go to previous video. First watch the previous video, then only you can proceed. Otherwise, you will not able to understand. Okay. So, today's topic is Turing machine formal definition. So, as you know, in every formal automata, we have the formal definition. Okay. So, a Turing machine TM is a mathematical model which consists of an infinite length tape divided into cells on which input is given. So, as I shown you in the previous video, what is the tape and what is the length of the tape and how it will be representing the infinite length tape, okay, and how to divide and how to merge that we are going to see after finishing some of the examples. Okay. So, the first thing is, in the formal definition of Turing machine, 7 tuples we have. Okay, 7 tuples. What are the things? What are the tuples? First one is Q, second one is X, third one is sigma, fourth one is tau, delta, and fifth one is Q naught, and sixth one is B, and seventh one is F. So, what is this Q, X, sigma, delta, Q0, BF? So, first one is Q. Q is a finite set of states. Example, like if we have the states like A, comma B, comma C, this is a Q, finite state of whatever the finite state, finite set of states are there, that is called Q. X is like, as I told you in the previous lecture, tape. So, whatever the values, whatever the alphabets we are going to use in the tape, that is X. Okay, I am representing the letter X. What is the sigma? Sigma is, already you know, already we done the previous problems and videos, like in FSM, finite state machine, and PDA, like 0, 1 example. This is a input alphabet. Okay, and I will go to delta. So, here Q0 is the initial state, you know, and the B is a blank state. This is a special symbol which is included in the Turing machine, okay, and that is representing as capital B. B is a blank symbol. F is the set of final states. Okay. Now, the thing is delta. Delta is a transition function. Delta is Q cross X. So, whatever the state we have and whatever the value, whatever the alphabets are there in the tape, that will give the value Q cross X. After that, it will move to the left shift or right shift. In the previous video, I shown you how it is moving from left to left side and how it is moving to right side. So, before going to this, you must know that, go to the previous video and see. Okay. Now, Q cross X is giving Q cross X cross, either it will go to the left side or it will go to the right side. And when it will go to the left side, if it is in the left hand side, it should not move to left, it will at the same place. So, this all the things I explain in detail. Okay. So, this is a formal definition of Turing machine. You need to remember this all 7 tuples, and based on this we can solve the problem. Whatever the problem, whatever the models are there, already we discussed in the PDA and FSM, the same problems we will solve with this Turing machine. Okay. So, the first example, okay, before going to the example, you must know the Turing machine, like recursively enumerable language. If you get in the exam, in place of Turing machine, if it is displaying like this, recursively enumerable language, that means that is also a Turing machine. So, a language L and sigma is said to be recursively enumerable if there exists a Turing machine that accepts it. Okay. So, whenever, as I shown you in the previous video, the graph like circle like this one, okay, recursively enumerable language, that is nothing but TM. Okay. This recursive enumerable language will come under in TM, Turing machine. Okay. Next, the example is, we in the question we have this question. What is the question? L is equals to the language 0 1 star 0. What does it mean? How we can read this? 1 0 followed by any number of ones. 1 star means any number of ones followed by 1 0. So, whenever we have the input string in this format, then only we can say that this is a language. Okay, this is a context free language. So, 0 1 1 0 1 0. So, how it will take? Like first one is 0, as it is telling 1 0 followed by any number of ones like 1 2 3, any number of ones, and followed by 1 0. This is telling, based on this language we can create the input string in this format. Okay. So, we will take this example and we will solve with Turing machine. So, what is the example? I will take color. L is equals to 0 1 star 0. Okay. So, here when we have like this, you must know we need to satisfy, we need to take the input string. I am taking the input string like this one, and I want to solve this problem with the Turing machine, TM. Okay, fine. Now, this is a deterministic and non-deterministic. You can see in the previous videos in detail is there. Okay, deterministic. Okay. So, here first of all we need to draw the state diagram, or otherwise just you need to take the tuples. What are the tuples we have? We need to take Q, X, sigma, delta, initial state like Q0, B blank, okay, B blank, and F is a final state. Okay. So, here I am taking three states. Like example, I can take ABC or Q0, Q anything you can take, whatever you want. I am taking A comma B comma C, and the X is I am taking uh, 0, 1, x, y, and sigma I am taking 0 comma 1. Sigma, the input is 0 comma 1 and x is x comma y, that is present in the tape. So, this will be the tape, infinite tape. Okay. Okay. Delta is there, we need to solve that. Q0 is, what is Q0? A, initial state is my A, and B is represent as this, and F is a final state. And final state, the two final state will be there. As we discussed in the previous video, first one is accept, second one is reject. First one is accept and second one is reject. That means in this problem we will get the two final state, either the string, the input string whatever you are giving, that will be accept or reject. Okay. So, we already found this. Now, we need to use the tape and we need to solve this problem. Okay. So, first, so here the tape is there, and in the tape I am taking the string 0 1 1 1 0, that is 0 1, and in the tape, as I told you, x value will be there. So, what is the x? We have the x comma y. X is representing 0, okay. X is representing 0, and here y, y and y. Then at the last must have x. After that, as I told you, this is a infinite size, length of the tape is infinite. So, blank will represent as this symbol and so on. Okay. And the tape header is this, tape, sorry, header. Tape head is first one. Okay. You can consider this is step 1. You can consider this is a step 1. So, now in this, if we follow the rules of Turing machine, so what is a Turing machine? First, I need to check only 1 0 followed by any number of ones followed by 1 0. Okay. So, let us see here. In the first step, we have the head on the x. In the x, that means whenever I have a 0, that will go to next. If I get the 0, then I can reach to next state. So, first here it should be in the second one. In the second one, it will have the tape like this 1, 2, 3, 4, 5, 6 and so on. So, here in place of x, whenever the head is there, that means x, whenever the 0 occurs. Okay. So, this should be cut and that should be add blank, because only I want 0 only one time. So, one time is occurred. So, it moved to next. At the right side it move and the values will be the same in the tape. The first value it will change, okay, and so on. Next, What is the next one? Next one is, this is my head. Here it is telling y is representing as 1. So, I will write here x is representing as 0, y is representing as 1. Okay. So, here the first one is empty. In place of 1, 1 means any number of ones, means it is also accepting, and empty, the rest of the values will be same. If you did not understand this, don't worry, we will draw the state diagram and again we will solve this. Okay. But first I am solving the problem with the help of Turing machine, then afterwards we will take the help of state diagram, then we will see. So, where is my header now? Header is here and it moved to right side. Fourth one, and whatever I am explaining you, write it in the note, because you will not find this kind of things on internet. So, this is empty, empty, any number of ones means this y also will get blank cell, and y x blank blank, and so on. In the same way, fifth one, now where is my header? My header at the right side, it moved to right side. So, that is in the fourth position. Now, again blank blank blank, y also is any number of ones. So, this is also satisfying. So, this is blank x, and this is blank blank, and so on. Sixth one, where is my header now? At the fifth position. In the fifth position I have, so here blank 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 blank, and this x means after any number of ones followed by 0. Yes, it is followed by 0. So, this is also accepting. The rest of the things are, and my header at the sixth position, and in the sixth position what I have? In the sixth position I have the blank, that means that is a infinite. So, whatever the string we have got, that with the help of this we check all in the tape, all the in alphabets are blank. So, that is accepted. Okay. If anything is wrong, if any number of followed by 2 zeros, then it will show you rejected, but here it is accepted. So, this is a small procedure. First, tape head at the first place, either it can move to the left side or the right side. If you go to the left side here, because you are at the left end of the tape, so you cannot move left further, because of that we can move to the right side. So, my next, in the second step, my header is in the second position. In the third step, my header in the third, and fourth step my header is in the fourth state, and fifth one is a fifth state. Sixth step I got on the sixth one, and the sixth one my alphabet is, we can say the alphabet or alphabet, that is blank. So, that means whatever the input values was present in the tape, that is completed, rest of the things are infinite. So, this is accepted. So, do not worry, I will show you here the state diagram of this. So, how many state we have now? Here, how many state I have? A, B, C. So, we will take that A, B, and See, I have 3 states. Okay. In the 3 state, initial state is A, that should be represent. So, A, in the A, when it is going to be, when A is 0, and arrow mark, this is x, means as I told you, x is 0, y is 1, or 0 is x, or 0 is 1. So, wherever the 0 is there, the value should be put in x, and it should move to right. Okay. So, what is this first one? Input, and it is changing to x. If it is x, then move to the right side. Okay. So, let us see here what we have done here in the first. In the first step, x is nothing but 0, and it is moving to the right side. So, next header is here, and here what is the value? That is empty. Okay. Or just you can write here x, y, 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 z, x. So, this is the one from A is 0, then it go to the R. If example, if my input symbol is starting from the 1, so this string is not accepted by this state diagram. So, here we need to draw rejected. What we need to draw? Reject. So, this is reject. When it will be reject? When we have the input symbol is 1, and that is represent as y, comma, it should move to. So, if it is 1, so 1 comma r. 1 comma 1 means 1 is represented as 1 only, and comma r. It moved to right. When it is moved to right, means why we are writing this, means if it is 1, it will go here, sorry, go next, whatever the last step of the blank cell, that will take and that will display here. So, blank should be reject or right, move right. So, it will go to the last here without solving this, then it will give you the reject state. Okay. And if we did not draw the reject state in the state diagram also, in the deterministic, automatically if it is not 0, it will go to the reject state only. Okay. Fine. Now, it is going from A to 0, A to 1. Now, B to 0 and B 1. So, first thing, B to 0, if B is 0, where should it go? 0, then go to x comma r, move to right. But here 0 and 0 is occurred, means what is our input string? 0 1 1 1 0. So, first 0 and the last 0 we got it. From A, if it is 0 x, then it moved to next, and from B to B is input symbol is 0, then x comma I move to r. But the middle of the triple 1 means any number of ones, that should be loop. In the form of loop it will be there. If it is 1, go to y, it changes to y, that is R. Input symbol is 1, then change to Y comma R. Okay, and this is a 0 and this is 1. If it is 1 from B, what it will be? Here, if it is, so here we can directly write, like here 1 comma 1 we have written, here 0 is to 0 we can write, but you will get little bit confused. So write it blank is blank comma R. That means if it is 1, it will perform this operation. If it is not get anything, then it will go to the blank state and it will go to the reject. And here also, if it is completed this 1, 2, 3, then it will go to blank comma blank is R, that is accepted, that is accepted. And if any at the last, after finishing the 0, what does that mean? 0? 0 means after this should not any number of things. So here 0 comma 0 is 0, move to R, 1 or 1 is to be R, right hand side. If we have this kind of value from C, then it should move to the reject. In this diagram I am showing the reject also, but in the coming state diagrams I will not draw the reject state, because if it is not satisfying this one, automatically it will go to the reject state in the deterministic. Okay. So this is about the simple diagram of this problem 0 1 1 0. Okay. Now again, once again I will draw one thing. This tape I draw. So here with the help of this, again I will draw the tape for better understanding purpose. Here, okay, this is a tape. In this tape we have the value x, y, y, y and x, here blank blank. As I told you, blank is not subset of input symbol. Okay. So this is my table head. So here if it is going from A to B, if it is 0, okay, then change to x. So here I am writing x, y, 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 x. So here we need to write the input symbols 0, then you can easily understand 0, 1, 1, 1, 0, blank, blank and so on. Okay. Okay. My header is here. If input symbol is 0, that should be replaced with x and move the header to the next here. What it is telling? If the input is 0, yes, my input is 0, then go to the x state, change to x and move to right. So from here to here it's move. And what is my header now? 1. So here in the B, 1. if 1 is there, it moved to its y and moved to it's moved to right. Cut it and move to right, this one. And what is my header now? This one. In the header, if it is again 1, so it moved to y and move to next. And here again it is 1 in the tape, then again it's changed to y and the header is moved to next state. What is the next state? Is 0. So B, if it is 0, then go to the x comma r. So this 0 will change with x and the header is moved to the next state. In the next state, what is the next state? In the next state, if I have any number example 0 or 1 something, then it will go to the reject state. But I don't have any number, any input symbol here, any input alphabet I don't have here. This is a blank. So if the blank is there, that should be replaced with blank and move to right, that is accepted. Your string is accepted. Okay. So this is a simple example. Once again I will repeat here. In the Turing machine, we have taken this example 0 1 star 0, that is input string is this one, and that is we are adding in the tape. Okay. And what is the deterministic tuples? We have the 7 tuples q x sigma delta q0 bf. So q is a number of states, x is a whatever the alphabets you are going to use in the tape. I am using 0 1 as well as x and y. Okay, 0 1 as well as x and y. Sigma 0 comma 1, only the inputs are I am taking 0 and 1. Delta is whatever we are performing the operation, like 0 x move r or left, whatever I am doing this is a delta. Q0 is the initial state, B is a blank, F is even accept string or reject string. So this is one example for the Turing machine. Okay. So this is a state diagram for the given problem. What is the, if it is 0, then go to the x and move to right. Any number of ones means we have taken the loop. We have taken the loop. Any number of ones can be allowed here, but starting and ending should be 1 0. Okay. In the coming classes, if we did not draw this also reject, don't worry, don't get confused. I have not drawn the reject, because in the reject, in the deterministic, remember this thing, in the exam also, if it is giving you the question without reject also, that is not wrong, that is correct. If you did not define the reject state in the state diagram, that means automatically it is going to the reject state. Okay. So remember this thing. So this is a about the Turing machines example 1. Okay. And we will do the example 2, 3, and we will take some of the examples and we will solve. Okay. So for today's class is about the Turing machine formal definition, and we saw one example, and this string is accepted. In the next class we will see some of more example. Okay. Thank you very much. We'll see you in the next class.